Hi, folks. This is Dr. Rob Cybus, the Carb Addiction Doc, and today I'm giving a foreword to a brilliant discussion I've just had with Professor Tim Noakes. This we recorded yesterday, and it's brand new off the press. Very, very few people have heard about this. If you are a performance athlete, if you are even just an average Joe like myself who's physically active, you really, really need to watch this video that presents a massive new change in our thinking about how the body uses energy and which cells matter and which are the organs that are important in the manufacture and the utilization of energy that governs performance, governs endurance, governs strength. It is an absolutely huge change in thinking, and Prof Noakes outlines it very, very effectively in the short teaser. So please watch the next 20 minutes and then bombard us with questions. I will try to answer every one of these comments. And if I can't, in discussion with Prof Noakes, we will come up with that answer. This is new breaking news, and I think it's going to transform the athletic world. I don't often embellish things like this, but it really is big new thinking. And you know, Prof Noakes did this before in 2010, 2012, when he ripped out the carb loading part of his phenomenally successful international bestseller called The Law of Running, and he replaced it with a low-carb, high-fat suggestion for optimizing nutrition for athletes. Well, listen to what he has to say in terms of a massive new revelation in this regard. I am the Carb Addiction Doc. Please leave comments, leave questions below. This is new, this is exciting. We'll explore this. We're just on the brink of a new athletic revolution. Hi, folks. This is Dr. Rob Cybus here. I'm sitting in Florida in the United States, and we've got this wonderful panel of people across the world that are all excited, have a vested personal interest in metabolic health and national nutritional health and international nutritional health. So we've got a very broad palette of things we're going to discuss today, but everybody has a personal story. Everybody is in a therapeutic space of some sort. And I think if you want to be a voyeur and listen in to how we think and how we discuss things and how we approach problems within a group setting like this, this is going to be an excellent, excellent discussion. And to start with, we've got Prof Tim Noakes, who has been in my life since I started medical school and is a major influence on what I do and who I am. And Prof, you come at this today from the athletic perspective, but from time to time, I am physically active. I'm certainly by no means an athlete. And, what we're talking about is what is the best fuel for athletes. But the question I really have for you is not just with performance athletes at upper level, but also regular Joes like myself. How does nutrition impact what we do? How does nutrition help us to sustain something that is not part and parcel of our bloodstream of our everyday? Do you have any thoughts on that? And what is the best fuel source for athletic endeavor?
You're muted, Prof.
So, Rob, if you'd asked me that question 2 weeks ago, I would have given you a totally different answer.
Wow.
And I've been in this field for 40 odd years. So then you have to say something dramatic happened. So I was asked to write a review on this very topic. And I started looking at the slides, which I would have shown you as a medical student. And I realized that we'd all overlooked something. And we've overlooked it for the last 50 years. So in very brief terms, there are two models we use to explain fatigue during exercise. The one is the limitations model, and the other is the regulated model. And limitations model is the one that we grew up with. And that is that if you start exercising, there's nothing going to stop you until you run out of fuel. Then you're going to collapse. And that has to be wrong, because that's not how the body works. We all know it's homeostatically regulated, but for some reason, exercise got just ignored that. But in this case, if it were true that you ran to exhaustion, your muscles would run out of glycogen and they wouldn't produce ATP, and you'd get muscle rigor. And muscle rigor never happens. So therefore, that model doesn't work. But not only would you get muscle rigor, your blood glucose would drop and you would kill your brain. So when I started looking at the literature with new eyes after 50 years, I went back to the original historic Scandinavian studies, which began with the muscle biopsy technique in the 1960s. Now, what happens in sports science is once you can measure something, you become the expert. And I was the first person to do muscle biopsies on athletes in South Africa. And that's how I became the expert, because I was measuring muscle glycogen. And that made me expert. So we spoke about the importance of muscle glycogen for all these years. And we ignored other stuff. And if you read Law of Running, you'll see it's all about muscle glycogen. So in the course of writing this article, which begins with that we start with models and the two models, in the course of writing that, I learned one thing which I'd never realized, and it is impossible for you to slow down the rate at which you burn glycogen during exercise. You can do anything you like, you can't slow it down. So that tells you from the moment you start exercise, there's nothing you can do to slow glycogen use down. Now, why would the body decide on that? And I can't answer that question. Have no idea. But we did experiments which only now do I understand the full implications of them, because we wanted to see when you're glycogen depleted and when you're glycogen depleted, you've got not enough carbohydrate on board. Why do you get tired? And what we did was we infused glucose at very high rates, as I know you've done in your PhD thesis. And guess what happened? Nothing. The metabolic response was identical because the body is protecting its blood glucose concentration, and it will not allow you to burn excess glucose from the bloodstream from your endogenous stores. It will not allow you to do that. And that's why you burn fat during exercise. You burn fat during exercise to protect the blood glucose concentration. That's the key. So anyway, then I go and finish the article and then look at the meta-analyses of, there are about 25 meta-analyses of carbohydrates versus fat studies where athletes have been put on both diets. And guess what? Absolutely no difference in performance. No difference. So the old idea that you have an obligatory requirement to burn carbohydrates during exercise is false. It may be true in a small group of elite, very elite athletes exercising at very high intensity. That's the small group. But for the average athlete, and one of the studies that is included in that meta-analysis is one that I did with Philip Prince in Pennsylvania and his team. And it's one of the best studies of carbohydrates versus fats, because in the study, we did repetitive measurements of 5-kilometer time trial performances. And there was no difference in performance. And it was a meticulous study. But what's more important, we had good athletes. They were better than 88% of all athletes in North America. And if they didn't get a benefit from carbohydrate use, then 88% of American athletes are not going to. And that means the vast majority of athletes globally do not need carbohydrates. The only time you need carbohydrates is if your blood glucose is going to drop. That's it. That's sports nutrition in one line.
That is a phenomenal insight, Prof. And I think it's such an important thing to get out there, because there's so much speak about the clash between what the best fuel source is and ingestion. And I think what you're really saying is, and there's two parts I want to explore. The first thing is this, that the human body has a tremendous capacity to store fuel as fat and as glycogen within itself, no matter how lean or how unfit or how fit you are. So it really begs two questions, because what people don't understand is the fuel that goes in your mouth is not necessarily the fuel that is stored. There is no store for protein, for example, and yet protein is a source of energy. There is an abundant store for fat and a limited store for glycogen that may or may not be increasable. The question, though, for me then, if you're a self-contained body with an inherent fuel source that you don't have external input into during athletic endeavor, is the problem, and this comes into Dr. Wellington's purview as well, is the problem then not metabolic access to that fuel? So, for example, in the majority of, I would say the majority of people in America right now, because the majority of people in America are insulin resistant, is access to that fuel source from where it's stored into where it's required, into the muscle cells, not a larger factor. You know, I can understand the inherent storage of glycogen. The muscles are the largest store of glycogen in the body, and they never get depleted. But is access to fuel not an issue? And whether you are fat adapted or whether you are glucose adapted, whether you're insulin resistant, how do we have any knowledge, any data that supports those aspects when it comes to athletic endeavor? I know you ran as a type 2 diabetic at some stage. What have you noticed personally, and what differences are there in terms of fuel access? Because it's not about one single cell. The body is supported by this tremendous multi-organ support system.
Yeah. And guess what organ is regulating the supply? It's the brain. The key is what you fuel the brain with. That is the class. That's the point. And so everything is directed to protect the brain during exercise. And again, these studies have been out in the literature, but they haven't been read. There's a study in 2003 by a group in Scandinavia, again, where because they always were ahead of the game, they measured brain glucose uptake. So they had to cannulate the external jugular vein and a major artery. And they did this, and they forced these people to exercise until their blood glucose were gone down to about 2 millimoles, which is, for most of us, we'd be barely alive at that value. And guess what they found? They found as soon as the glucose starts to drop below about 4 millimoles, remember in diabetes, in health, we try to keep the glucose between 4 and 5. But once it goes below 4, cerebral glucose metabolism drops, and overall glucose brain metabolism drops dramatically. So the brain stops working once the glucose drops below about 4. And what does the brain do? It says, hold on, there's only one way I can save you from dying, and that's to stop you exercising. And that's the reflex. So we developed, obviously, the central governor reflex, and because we understood that during maximum exercise, you don't want the heart to become ischemic, and so that you protect it with this mechanism. But no one, including myself, has described it for hypoglycemia, but it's very clear that is the main determinant of stopping you. So what these guys found is that if you then reverse the hypoglycemia, then the brain metabolism is improved and performance can go up. But critically, in these studies, the glycogen use doesn't change, so that you've got a person who's totally exhausted and they can't move. You give them glucose, they can continue for another half hour or so, but their muscle glycogen use doesn't increase. So therefore, it wasn't the muscle glycogen that stopped them, it was the hypoglycemia. And that's absolutely logical. So to get back to the whole story, it's very clear that the first thing that goes wrong in prolonged exercise is you become hypoglycemic, or your glucose starts to drop, and the brain isn't going to let it become hypoglycemic. It's going to say, no, hold on, this thing's dropping. I can't allow you to continue. It'll slow you down. So you'll slow down, and you may or may have symptoms. Then eventually something else happens, and I can give you all the carbohydrates and all the glucose and all the fat, you'll still be exhausted. And we mustn't confuse the two. So carbohydrates work initially for a short time, and then they don't work anymore. And then that's a more complete fatigue, where the control is from all the rest of the body. And I know that you're particularly interested in homeostatic regulation, but that will be all the other mechanisms. So in brief, we have to tell people, nutrition plays no part in sporting performance. How's that?
Well, Prof, let me stop you there for a second, because we focus very heavily in the ketogenic world on fat adaptation, where we try to get people into ketosis. And we know, for example, with our type 1 diabetics, sometimes they'll overdose on insulin and their blood sugars will drop into the 20s and 30s. And most of the diabetics on a high glucose diet will feel awful at that level, if not pass out or have a seizure. So it's a crisis to get sugar into them. But a type 1 diabetic on a ketogenic diet can feel asymptomatic with blood sugars of 20 and 30 because their brain, as you said, is being supported by ketones. So the question I have for you then is there any value to becoming fat adapted as an athlete so that you can support the brain primarily with non-esterified fatty acids and ketones, to supplement the lack of glycogen or glucose? The second question, just from a personal, and these are A and Bs, but from a personal anecdotal perspective, we wear CGMs a lot, and a lot of my patients wear CGMs. And I find when I'm doing a protracted, for me, I'm not fit. But in fact, the paradox is that I see a surge in blood sugar before a massive drop. So there is a protective surge before you hit that wall, if you're going to hit the wall. And I've seen blood sugars, now I'm in American units. The last run that I did, and I've talked about this, I saw blood sugars of 170 milligrams per deciliter before I dropped down and hit that fatigue wall. So there's kind of this last-ditch effort by the body to give you that extra sugar, and then the hypoglycemia, and it may be an insulin response to that the surge of insulin from the hyperglycemia, and then you're not feeding yourself in the drop. But the first question is about ketosis, and what are your thoughts on that?
Absolutely. I think we focused on the wrong organ in exercise. We focused on the muscles instead of the brain, and that's the problem. Now, you're absolutely correct, because in those studies I spoke to you about, where they forced these people to become hypoglycemic, and then they measured brain glucose metabolism, the ketones couldn't contribute. They didn't, because the people were not fat adapted. So and the ketone levels only rose to 0.3 or 0.4, and they couldn't substitute for the loss of glucose. And obviously what happens when you're fat adapted is that the ketones can now substitute and provide 70% of the energy, and that's the difference. And so absolutely, if you want to know what to do to feed your brain during prolonged exercise, become fat adapted. There's no argument. And I think that's what people are learning. But the people who benefit in that way are the only people who are going 4 or 5 hours of exercise, and they will notice the difference. If you're doing half an hour's exercise, you're not going to notice any difference, because you're never going to become hypoglycemic. But I think there's no question that if you're exercising for more than 3 or 4 hours, to be fat adapted offers you an enormous advantage, because once you start running out of glucose, the ketones will substitute in the brain, and you won't notice it. And therefore you don't really need to eat or drink much extra carbohydrate.
So Prof, how long does it take to become fat adapted, do you think?
Well, the data show within 4 weeks, you can generally get your performance almost back to normal. And then it stays pretty much the same. But I think that the fat adaptation for the brain probably takes a bit longer. In the elite athletes I've spoken to, that some of them said it takes 3 to 4 months to get fully.
And actually, the data that we have, and it's data reporting that we have, primarily measuring insulin and C-peptide decrease to where people, and ketosis. And we start to see a difference at about 4 months, and then really start to see it in the 6 to 8 month period, depending on how insulin resistant they were. So doesn't that negate the majority of studies that are relatively short-term studies in non-fat adapted people?
Yeah, and you're quite right. The longest studies are about 12 weeks. But by 12 weeks, the performance is exactly the same. So we don't have to go longer than 12 weeks to show that the benefits are already there. But these are laboratory studies. And of course, people are individuals, and we know that. And there'll always be outstanding differences. So my great friend Louise Burke, who's done some of the really good studies, which I had to criticize very seriously, because they became the gold standard. And they showed that after 3 weeks, Olympic quality race walkers' performance was impaired. But you know what I discovered looking over the last 3 weeks was that when they did the time trials, the low carb group were not given glucose during exercise. During the exercise trial, they were not given glucose, and their blood glucose levels were much lower and tending to drop. So the whole effect could have been a glucose ingestion, failure of glucose ingestion during exercise. So anyway, the point about that slide, that talk, was that paper became very well accepted around the world as absolute clear evidence that elite athletes' performance is impaired. But there were major problems. And the one big problem was that in the second study they did, where they allowed the athletes to compete in a major event during the trial, 4 of 8, I think it was. It was 4 of 11 of the people on the low carb diet produced lifetime best performances.
Wow.
And then they said that the performance were worse. And in the control group who continued, I think it was 5 of 11 or something. It was slightly more, but there was no statistical difference. And then the final story was that the guy who won the Olympic gold medal, I think not at these Olympics, at the previous one, was the one guy who didn't follow the diet. He didn't follow a high carb diet. And he said he benefited hugely from following the low carb diet. And so I mean, I would have absolutely no doubt if I was advising an athlete who's running an ultra marathon beyond, you must eat a high fat diet. That's the only solution. It's going to be the best for you.
So, Prof, this is very intriguing new data. And I want to extrapolate this to the rest of the panel from this perspective, is that you've made a huge leap that I think favors us mere mortals, not the non-athletes, in that you said two things. First of all, you spoke about the muscles and performance, and it really isn't that the muscles are kind of bystanders in the process of substrate performance, and it's really the brain that's the issue. So when it comes to energy consumption by the brain, it is not just physical athletic endeavor. I know when I'm a surgeon, and when I'm doing a particularly exhausting, harrowing case, I'm standing there, my arms are hardly moving, but my brain is functioning hopefully at a very high capacity. And us mere mortals who are working each day, that have the fatigue and the somnolence through the day, surely the same principle is happening for people. If it's a global somatic glucose substrate problem, is the same thing not happening to us? And I'd like to segue across to Dr. Wellington, because he deals a lot with the endocrine issues with insulin resistance and diabetes. And generally as a society, even expanding it beyond illness and toward just general health, is our society then not much more able to function as individuals and collectively at a higher, more productive level when we have a stable source of sugar going to our brain that supports the brain function? So this has ramifications to a societal level, but also for our diabetics. And I think, Dr. Wellington, the first question I really have for you is, what is insulin resistance, and what does that mean at a cellular level to how cells function? The video you've just watched is a short segment from a much larger interview I did. I moderated a discussion group for the World Nutrition Summit that's coming up in March of 2022. And as part of that, the introductory speaker was Prof Tim Noakes, but he does speak further. He embellishes more on what he's just talked about in further parts of the video. So later on, in the next few weeks, that complete summary video will drop. It'll be called the World Nutrition Summit video, and it is a teaser, but also about an hour and a half long conversation with several people that are going to be presenting their work in March of 2022. And in fact, Prof Tim Noakes is the keynote speaker at this, talking about energy and fuel use and fuel utilization by the body for athletes. That's upcoming in March. But I will be releasing our video on this channel later on, and there'll be more from Prof Noakes at that time. But really, in summary, what are we talking about? We're talking about how the entire human body works as a single organism. This is not about individual cells. It's not about muscles. It's not about the liver. It's not just about the brain. This is about how the entire organism that is us as a human body manipulates and utilizes and influences how we perform, what makes us perform at peak level, and what causes us to crash and burn at various times. And this is so important for the average Joe like myself to understand, but also for the performance athletes to understand. And it's a radical change in our thinking and understanding of how fuel works. Becoming fat adapted is, in both Prof Noakes and my opinion, crucial to the ideal athletic performance, where you condition your cells to be able to burn ketones as well as sugar. But it also does change our context in terms of the importance of sugar and the importance of ketones and fat, both for our muscles, which has been the focus of most athletes. Most athletes intuitively focus on their muscles, but there are other organs involved, the liver and in particular the brain. And really the brain, and fuel for the brain is at the center of athletic performance. Think that through, folks. The brain is at the center of athletic performance. It is not the muscles. The muscles almost never run out of fuel. Think about that. We used to think, okay, even Prof Noakes used to think the muscles run out of fuel and then we bonk, then we crash. Not true. Not true. It's the brain that runs out of fuel because the brain is the quarterback of the muscles. And how your muscles work and how your muscles function and the effectiveness of performance is governed primarily by the brain and the nervous system, not just the musculoskeletal attributes. Of course, the musculoskeletal attributes, they are affected. The length of your bones, the strength of your muscles, all of those things are important. But the brain is the quarterback. And it's a huge change in thinking because the brain is the most important organ in terms of fuel substrate, energy and calorie substrate for performance, not the muscles. Interesting thoughts. We're going to explore this further down the road and enhance on what we've talked about so far. So please bombard us with questions. We're exploring this, but Prof Noakes has eons of knowledge, and I'm tapping into that. I'm a conduit. Please, please, please leave your comments below. I am the Carb Addiction Doc. If you would like a consult with us, text us, WhatsApp us, 561-517-0642. I hope this resonates. And I would urge all of you also to sign up for the World Nutrition Summit. It's occurring in March, the 24th to the 26th of March. It is an international conference following the one of 2021. And Prof Noakes is the lead speaker, and he's talking about optimal fuel utilization for athletes and for athletic performance and his change in thinking. But this is a phenomenal, phenomenal summit, and I would urge everybody to get tickets. By the way, I am the Carb Addiction Doc, and if you look in the show notes below this, there is an affiliate link where you can get quite a significant reduction on the cost of your tickets for this event. So sign up, join us, educate yourself. Let's make you think. I am the Carb Addiction Doc. So appreciate Prof Noakes' insights.